Okay, just now we stopped at corrosion resistant. What I mean by corrosion resistant means that things that help you to protect from corrosion. Yeah? So these are the list of um, materials that commonly used in the seawater system. So you can look for this table. So for pipe, for example, pipe they use galvanized steel, pipe casing they use cast iron, and so on. Okay. So there are two category of material. One is on the low cost, one is the low maintenance system. Okay. So those sea operator or seawater operator, they will choose either one, or maybe they have a mixture of these two. Huh? So the material can either be low cost system or under low maintenance system. Okay, so the information is inside the table. And this one is another continuous from the table. Also same, this is the component, this is the low cost, this is the low maintenance material. Okay. Next, we look at the effect of velocity on the corrosion of metals in seawater. So from this table, on the left-hand side, you see the alloy, the type of alloy, carbon steel, and so on. On the middle and on the third column, you have a quiet water and flowing seawater. So you can see that for the average corrosion rate, you can see that there's a changes of value over here. So the deepest pit is like this. Okay, the deepest pit you can find, and the flowing water is having this value. Okay. We have done with corrosion in seawater. Now we talk about corrosion in soil. So why we talk about soil? Because usually in construction, we hide our pipe in the soil. So sometimes you hear the news of pipe burst or there's a leakage of chemical into the river and so on. So most of the time is because of the corrosion happen that contribute to all these disaster. Okay, so this is the definition of soil. Soil is aggregate of, or is a consists of minerals, organic, water, and gases. When you talk about soil, we need to go deep into definition here. So when you talk to soil expert, normally they will tell you about the soil profile and soil horizon. What I mean by that? So if you look at this diagram, so this is a soil, then you cut across the soil. This is a cross section of the soil, means you excavate, you dig all the soil in this way. So you cut across the soil. Then this is the projection, 3D projection of the soil. Okay, now what mean by soil profile? This is called soil profile. Soil profile consists of O, A, E, B, C, R. Okay, when you use the word soil profile, or if you see the question asked about soil profile, it means it expects you to look into vertical cross section, meaning you look at O, A, E, B, C, and R. Okay, O stand for organic at the surface here. At the first level, under the grass, you see there's a black soil, which consists of all the dead body and organic matter. Then you have the topsoil, A. O and A. O is the most first layer. A is the topsoil. Then you go into horizon, E, and you go to subsoil, you go to parent material, and you go to rock bed, which is at the bottom of the profile. Okay, profile means the whole vertical cross section. When you talk about soil horizontal, it means layer. Soil horizontal means layer. So layer R, layer C, layer B, layer E, layer E, layer O. It means that if you combine these two statements, soil profile actually consists of different soil horizon. Again, soil profile consists of different layer of soil horizon. I repeat again, soil profile consists of different layer of soil horizon. Okay, ask yourself this question. Do you understand the differences between soil profile and soil horizon? Okay, soil profile consists of different layer of soil horizon. Okay. So these are the alphabet that we use when we talk about soil profile. Each layer will contribute to corrosion and happen at a different rate. Okay, so we're going to talk about the properties of each layer, and then we try to find the reason why corrosion can happen and what contribute to the corrosion rate. Okay, so O, A, E, B, C, R. So I think this one is the new chart or new term for the second half of the lesson. O, A, E, B, C, R. Okay. Okay, let's move on. So this one is available in your handouts, right? Let's move on to corrosion in soil. In tropical region, for example, Malaysia, these are all the example of soil corrosion happen. Soil corrosion happen in oil, gas, water pipeline, gas station, especially the storage that you bury underground, something like this, right? Electrical communication cable, like the telecoms, your Wi-Fi cables and all this, wells and shaft casing. So this is the cross-section of all the pipes that you have in the neighborhood, in the resident area. Okay, you have all the wastage tank and so on. And this is the underground water. Then classification for soil, they have a table for classification. So when we talk about soil texture, it look at the particle size. So there are some value that you can link to. For example, for sand of very coarse, the diameter of the particles or the sand size is between 1 to 2 mm. It fall under very coarse size. If the sand size or the particle size is less than 0.002 mm, it fall under gray category. Okay, so for soil, this is the table that you describe about the soil texture. All right. There's a message coming. Mohit, are you there?
Yes, sir.
Okay. All right. So I'll show you the penetration of water in a different kind of category here. So if you compare clay, silt, this one, and sand, and you drop water on the same rate on the bottom, you can see that if you're dropping the same rate of water from the surface, sand can penetrate water, can let the water to go through very fast. Silt a little bit slower, but clay, it will tends to hold water at the surface. Okay, so when you talk about corrosion in solid, you link with this table, link with how water flow inside the mechanism, inside the system, then you manage to score some marks for that. Okay, so when you talk about corrosion in soil, you think of this table, you think of the particles of size category, and then you capture this image, then you explain how water flow inside the soil texture. Okay. Okay. So this one I already showed in this diagram. It means clay will try to retain water, but soil with, for example, soil with very coarse, it can flow water very fast from the surface until the bottom. Okay. Based on soil, this is the category. Based on soil, there's one soil identification system. It can further divide the soil type. Okay, further divide the soil type into 11 type of soil. Okay, by comparing three main components inside this table. So basically, if you look at this table, there are only three main component, which is the sand. You see this one, the sand, silt, and clay. Okay, so based on this table, actually there are three big family: sand, silt, and clay. So there's one system that identified type of soil. They have 11 types by looking at the percentage of clay, silt, and sand. These are the name for the identification system for type of the soil that you have. There are 11 types of name that consists of clay, silt, and sand. Okay, so for under soil, you should understand how do you classify soil. Okay, based on particle size. Then in the particle size, you have three big family: sand, silt, and clay. And you mix different percentage of sand, silt, and clay, you generate another 11 type of soil. Okay, so there are lots of name there, so you can come back to this later. But what you need to take home is that you know that how you categorize soil is based on texture. So based on texture, you have three big family: sand, silt, and clay. And by mixing different type of sand, silt, and clay, you can generate 11 type of soil system. I give you a picture. Okay, this picture will illustrate the 11 types of soil over here. Again, three main family: sand, silt, and clay. Sand, silt, and clay. So if you have clay, 100% is a clay. If you have 100% of sand, you have a sand. If 100% of silt, you have 100%. You have silt. What happens if you mix 85% of sand with silt and go a little bit more, 70%, you get a loamy sand. over here, when you have 50% of sand, you get a loam. When you have 20% of sand, you get a silt form here with a little bit of clay also, right? Sand. So this will give you some idea. Where is the name fall into? Huh? So for example, clay loam is quite balanced. Clay loam consists of clay, sand, and silt in a very balanced percentage. Okay, so later you can look into this diagram, but there's a diagram for you. All right. When you apply this table or the name of this one, when you work with civil engineer, when you work in a civil engineer that need to build houses or need to do something about soil, okay, then all this name will come into the conversation. Okay. There's also another table for just now there are two systems. There are two main systems for classification. One is based on particle size, sand, silt, and clay. This is the old system. Okay, this is the old system to classify soil based on particle size, sand, silt, and clay. Another new system, they use hierarchy approach. They use hierarchy approach where they have a standard, they have a table to refer to. For example, table 2.25 is based on hierarchy approach. So for example, they look into other dimension. So they can group the soil based on order, based on suborder, based on grade group, based on subgroup, based on family, and based on series. Okay. So there are different category you can classify your soil. You can group your soil if you're using hierarchy approach. You can classify your soil using order, using suborder, using grade group, using subgroup, using family, using series. And these are the explanation of or summaries of each type of category. Okay, you can read now this table from the classification. Next, we talk about soil parameter that affecting corrosivity. This is a simplified diagram for nature of corrosion, how corrosion can happen in a soil. So we start from the top. The soil will, okay, the soil, I think this one will help for your revision also. Soil will help the aeration. Okay, again, what is aeration? Is the mixture of oxygen. Aeration means how well it is mixed well with oxygen. Aeration, the wording is you tie with oxygen. Okay, aeration means you mix with oxygen. Next, you look at moisture. It must look at resistivity. Then you calculate the rate of corrosion. Okay, type of soil, aeration, moisture, resistivity. Then you can calculate or you can define the rate of corrosion. Another way, after aeration, okay, this side is more on this side is more on the bacteria, side now. This one, this side is more on bacteria. So anaerobic, if you learn in biology, anaerobic means a living creature that operates without oxygen. So without oxygen, the bacteria, some bacteria, they're still able to survive. So they create some ingredients to the corrosion for the corrosion process. Okay. The next you will look into it further. So this is just a schematic diagram of flow, how variable inside the soil can affect corrosion. Okay, so there are some important variables that influence the corrosion rates in soil. Okay, so this is also one of the area we like to ask in the final exam. Okay, so 1, 2, 3, 4, 5, 6. So there are 6 criteria. There are 6 criteria or 6 parameter you use to explain corrosion rates in soil. First, water. Second, degree of aeration. Again, degree of aeration means the mixture of oxygen inside the soil. pH, all corrosion parameter relate with pH. Redox potential. Redox potential is, later I show you the diagram. Resistivity and ion species, especially when you have salt. Okay, salt here means you link with the Cl, correct. Okay, let's look at another one is bacteria, microbiological activities. Right. First, we look at water. So what can water contribute to the corrosion rates? So underwater parameter, you can break this under soil. There are 2 types of water, saturated water and unsaturated water. Okay, I'm not going deep into what is saturated and unsaturated water. You learn this one in your thermodynamics. All right. So we focus on saturated water. Saturated water is important for under soil environment. Okay. And water movement in the soil can affect the corrosion rates. So how water move in the soil? How water move in the soil? Mechanism means how you do it, right? So I'll give you all the answer here. So you have 4 ways water move in the soil. First, through the most basic one, gravity force. If you drop water, water will flow from high ground to low ground. Second, capillary action. This one you learn about capillary action, especially you have a tree plantation with the roots. So you have all this capillary action, right? Even in the soil, you have different particles just now. They make up all the small room inside the soil. So they will create this capillary effect inside the ground. Second, osmosis process, osmosis pressure, which is something like this diagram. Okay, so you can see the water will flow from, maybe I go back to, okay, osmosis process. All right, you learn this one in biology also, osmosis, where water can flow from one side to another side using a membrane. So in the soil, sometimes you will have membrane in the soil. You create one type, the membrane mechanism inside the soil. For example, if you have a overlapping of different particles of soil, then you'll form a layer of similar like a membrane that it will create the osmosis process. Another one is electrostatic interaction with the soil particles. Sometimes the soil particle carry some positive charge, negative charge, and water H2O will attract to all these electrostatic charges. So this 4 is important. This 4 mechanism is important when you talk about water, how water in a soil affect your corrosion rates. Next, we talk about degree of aeration. Degree of aeration means how you mix with your oxygens. And how you mix with oxygens, it will tell you the concentration. Okay. Now, one fact, if you look at the profile here, oxygen concentration decrease if you go deeper and deeper. Oxygen concentration drop if you go deeper and deeper. Okay. Why oxygen is important in soil corrosion? Because oxygen concentration is important for catalytic reaction. I repeat, oxygen process or oxygen's element is important for cathodic reaction. Cathodic reaction. This one we covered in chapter 1 already. Okay, so how oxygen affect corrosion rate in soil? The keyword you need to remember, because oxygen is important for cathodic reaction. Okay, and the texture of your soil, it affects how the oxygen transport from one point to another point. Okay, imagine you have a coarse texture and clay. Coarse texture will manage to transport oxygen more effectively compared to the clay, right? A waterlogged texture. Another one is that when you disturb the soil, what I mean by disturb the soil? You go and dig the soil. When you dig the soil, there's a mixture of oxygen, right? Compared to those stagnant soil. So those at the bottom there, you do not touch it. So when you do not touch it, there is no mixture of oxygen, so they are lack of oxygen. And the oxygen also used by the bacteria also. So there are less oxygen as you go deeper. Right? So there are a few points when talk about oxygen. First, cathodic reaction. Second, the texture of the soil, how the oxygens move within the soil from top to bottom, and how the disturbed soil and undisturbed soil affect the aeration. Okay, when you dig when you dig and loosen the ground, you mix the soil with oxygen. When you don't do anything on the soil, you don't disturb the concentration, right? Next, pH. Again, pH, you think of two things, H positive and OH negative. All right. So soil, pH will be 5 to 8. Okay. Soil will be 5 to 8. It is, sometimes it can be acidic, sometimes it can be alkalic, but it stay within 5 to 8. How soil become acidic, right? How soil becomes 7 to 5? It is because of all these reason, all these factor. Maybe the soil is near to the industrial area. Remember, we have in the environment corrosion, we have 4 types. We have rural, urban, industrial, and marine. So when your environment is near to the industrial area, so the industrial waste can contribute to the soil acidity. And by nature, some of the trees or plantation, when they rot, when they die and they decompose, they will create acidic compound. For example, coniferous tree needles. This one in the Europe side, those that have a winter, Christmas tree. This is one type, like something like Christmas tree. When they die and they decompose, they will create compositions with acidic. Okay, some is from the nature, from the plant itself, right? Second one is from the human activity. For example, industrial waste, acid rain, right? Acid rain because of CO2, and some of the bacteria activity also. Okay, some of the bacteria activity when they have activity inside the ground, they consume and then they produce acidic products. Right. How's the soil move to the alkalic region? Very high chances is because of the content or the mineral that you find in that particular area. So if you have a high sodium, high potassium, high magnesium, high calcium, then that area of soil will be more towards alkaline. So sometimes quite interesting also how people find there is a limestone around the area. They test the pH of the ground. Okay, so if you want to find limestone, you look for the pH because limestone consists of calcium. All right. So just to give you an example, magnesium and calcium, they are very good in corrosion protection. Huh? Magnesium and calcium, they are very good as an agent of protection for corrosion. Okay? Because after they mix in the chemical process, they form a film, right? They form a film on the surface of that object, and they protect from further destruction of structure. Next is redox potential. So redox potential is linked to aeration. Okay, redox potential is linked with aeration, means the oxygen concentration. It's just a description. What happens if you have high redox? If you have high redox, means you have high oxygen content. Okay, high redox potential means you have high oxygen level. If you have low redox potential, means you have low oxygen concentration. So basically, redox potential, they are linked with aeration. Huh? Resistivity. If you in the soil engineering, this parameter resistivity is the popular parameter they use to tell you the type of the soil. Okay, because this one they can measure. Okay, resistivity you can measure, use instrument, and from the reading you can tell the activity of corrosion in that area. Okay, so resistivity, it link up with the ionic current flow. So if you have a high soil resistivity, meaning there are low corrosion activity there. Okay, you have high resistivity, means you are able to resist corrosion, means there are lower corrosion rate in that soil. Okay, on the resistivity factor or parameter, if you have a high soil resistivity, it means that if you have high soil resistivity, means that soil able to protect you from the corrosion. Means it's going to slow down the corrosion rates. Huh? Okay, so this is just elaboration on the resistivity. So if the soil do not able to protect the object from corrosion, means very low resistivity. So very low resistivity, normally in that area, you have very high water content and you have an ionic species. For example, you have a H positive, or even very high concentration of OH negative. Too alkaline also not good. Too acidic also not good. Because if you have too alkaline, then you're going to peel off the protection layer, right? And there are three techniques to measure the resistivity. Werner 4-pins technique means you hammer four metal pins on the ground, and then you use instrument to measure the resistivity of the ground. Another one is electromagnetic measurement and soil box method. There are three methods to measure resistivity. I'll show you one video on measuring the resistivity using Werner 4-pins technique. Okay, so at least when you see somebody, some engineer, plug something on the ground and there's a machine box he's looking at, meaning very high chances that this engineer is doing soil analysis. Okay, so from this video, I show you how's the Werner 4-pin techniques, quite popular in civil engineering. So don't surprise you as student who graduates who learn about mechanical, you might be working in the civil construction site. You will see your colleagues doing resistivity tests in the site. All right. So because in the video you see how resistivity going to affect the reading, going to affect the type of the soil for piling and all this. Next is on the species, ionic species on the salt. I will just give you one example corrects that we mentioned just now, Cl, our friend. So Cl will take part in the anodic dissolution reaction of metals. Also, we covered in chapter 2 of this module. So chlorides, that tends to reduce soil resistivity, meaning if you have higher chlorides, means the soil is more easy to corrode. Okay. Again, high resistivity means you able to protect the parts or the metals. High resistivity means you're able to resist corrosion. If a low resistivity means it able to is allowed corrosion happen in a faster rate. Okay. This is another application of what we learned today. When you deal with oil and gas industry, when you have a drill bit that drill underground, or maybe you involve in the city development that you have a big ball or you need to dig tunnels for the highway, then sometimes you need to dig a hole very deep into the level over here, and you will encounter underground water and also some of the decomposed geological seabed there. Okay, so this one is more on the if you're involved in the oil and gas. Sometimes you need to consider the ionic species for the corrosion because you need to protect your drill head and all this, maintenance for your drill head. Next on the biological activity, this one is more on bacteria. So one popular word is MIC, which stand for microbiological influence corrosion. MIC is one type of corrosion that link with the bacteria activity. All right, or we call it microorganism. Okay, microorganism is more correct technical word when we talk about MIC. Okay. So generally, this microbiological activity happen on the top layer here between O and A. Excuse me. Between O and A, you will have microbiological activity. So one of the example I'll give you in this video is one type of fungus or mold that contribute to the corrosion also. Okay, they create a slime on the surface that contribute to the soil property. Okay, so microorganisms that contribute to the corrosion in soil, you have four microorganisms that contribute to the corrosion because of microbiological activity. One, you have anaerobic and aerobic. Okay, anaerobic and aerobic both create acidic solution or chemical. Fungus and slime former. Slime former is the video or the photo that show you the yellow color on the ground one. That one is a slime former. So you're going to create the corrosion element for the process. Okay. So these are the table of summary of the bacteria that associate to the soil corrosion. You can read this table. Okay. On the far left is species of bacteria. Okay, species of bacteria, what they can do to the corrosion. Okay, you can have a read over here. Okay, with this, we conclude chapter 3. Let me end the recording.